Okay, so let's balance this equation. This is problem C on worksheet number 1. So we have a combustion reaction and we have to balance the reaction. And balancing means you're going to have the same number of atoms of each element on each side of the reaction. So this side is reactants, and on the other side of the arrow is products, okay? So I'll be referring to it as reactant side and product side. The reactant side has carbon, hydrogen, and oxygen, and product side has the same atoms, carbon, hydrogen, and oxygen. So first thing I like to do is line them up, and then I count how many of each one I have on each side. So on the reactant side, I have 5, right there, 5 carbons, 9 hydrogens, and then 1 plus 2 oxygens, which is 3 oxygens. And on this side, I have 1 carbon, I have 2 hydrogens, and then I have 3 oxygens. So let's start with carbon. So remember, the idea of balancing is you want to balance the number of atoms for each element so they're equal on each side. On each side. Okay. So if I have, I'm going to use a different color. So I have 5 carbons here. I want 5 on the product side. So I'm going to add a coefficient of 5. So now I have 5. Remember that coefficients are the large numbers in front. So the 5 I just added is a coefficient. These numbers, this right here is a subscript. So subscripts do not change, okay? But coefficients do change. We can add those. Okay, so we just added 5 there, but since we added a 5 in front of this carbon dioxide, now I'm saying I have 5 carbon dioxides, which means yes, I have 5 carbons, but I also have 5 more dioxides, which would be 10 on this side, plus the 1 from here. So now I have 11 oxygens. Let's match hydrogens then. So I have 9 hydrogens on this side, and I have 2 on the product side. So I need them both to match. So I'm going to think of what factor do they both have in common, and the lowest factor is 18, which means that I'll have to add a coefficient of 2 to get 18 here. And on this side, I add a coefficient of 9 to get 18 hydrogens, right? Because 9 times 2 is 18. And then 2 times 9 is 18. So my hydrogens match, but do my carbons still match? Because I added this coefficient here, now I have to change that number. Is no longer 5, it is 10, because now I have 2 of this molecule. So I have 10 carbons on one side and 5 on the other, which means that now I have to change this to 10 also. So I'm going to take out this 5 and I'm going to put 10 here instead. So now I have 10 carbons, but remember that if I change the carbons, I also have to change the oxygens and carbon dioxide. So now I have, instead of 11, I have 21. Actually 29. Because there are 9 oxygens here from this coefficient, and then 20, 10 times 2. So I have 29. Let me write that better. I have 29. And then on this side, I don't have 3 anymore. I have 4. So the 29, right? The carbons match and hydrogen match, but my oxygens do not, they're not balanced. So I have to balance them. So I'm going to play around with the coefficient in that number. All right, so I have 29 on one side and 4 on the other, which means that I need 29 oxygens on this side. So I'm going to, and by this side I mean reactants, and so I'm going to try and figure out what coefficient can I put here that will give me 29 total on the reactant side. So I'm going to just include, I'm going to take out this O2 right now because I want to figure out how many I need. And so I'm going to say I have 2 oxygens just from this molecule. I just have 2 oxygens. So I'm going to say 29 minus 2 equals 27. That's how many O2s I need. I need 27 O2s. So each O2 has 2 oxygens, and therefore I'm going to divide 27 by 2 to figure out how many O2s I need. I need 13.5 O2s. So I'm going to put that number right here, 13.5. Okay, you can't have a 0.5. You need a whole number to be a coefficient. And so to make that a whole number, we're just going to multiply it by 2. But because we're multiplying that one by 2, we're going to multiply everything by 2. So I'm going to rewrite this. So instead of 2C5H9O, we're going to have 4C5H9O plus 27O2 plus 20 CO2 plus 18 H2O. And if we count, we should get now equal amounts of each element on both sides. So I have 20 carbons. I have 20 carbons. I'm going to, I'll leave the color. I have 36 hydrogens, and on this side, 18 times 2, right? I have 36 hydrogens, and then finally oxygens. 4 plus 54 is 58, and on this side I have 40, right? Plus 18 is 58. So everything checks off. And if you were on the Zoom call, then you noticed when I made a boo-boo, and that was because I included this 4 when I was trying to figure out how many O2s I needed. But I needed to remove the O2, so I didn't have 4. I needed to just include the oxygen from this carbon molecule to make this calculation work, okay? So if you would have included the O2, you would have used 4, and instead of 27, you get 25. And that would actually make your equation unbalanced, as some of you saw. So the correct answer is 27 as the coefficient here. And hopefully that helps. So this is problem C.